Alright, in this video I'm going to be going over the solutions to the first semester final exam study guide. So this will contain a lot of problems that deal with many of the subjects that we went over in the first semester in pre-calculus. So let's go and start. I don't know if I'm going to get through all of the problems, so this will have to be cut in a few videos, but I'll get through as many as I can in the first video. So here's the first problem. And the first thing we'll do is determine if it's odd, even, or neither. So in order to determine if it's odd, even, or neither, we are going to need to plug in negative x into our function here. So we're going to get 3 negative x cubed minus 2 negative x all over negative x squared minus 4. Simplify that out. Now negative x cubed is going to give me negative 3x cubed plus 2x over negative x squared is just x squared minus 4. We're going to factor out a negative from the top. Over x squared minus 4. Now this negative at the top is the negative for the whole thing. So this is negative, and then the whole thing here is 3x cubed plus 2x over x squared plus 4, minus 4. Okay. We only need one negative, either the top or the bottom, to make this entire fraction a negative. Now notice here that this is the same thing as our function. So we get negative f of x. So if f of negative x is equal to negative f of x, then this function is odd. Okay. If f of negative x had equal f of x, if we didn't have this negative here and it was the exact same thing, then it would have been even. Otherwise, it's neither. Alright, so let's find the asymptotes. So the vertical asymptotes happen where the denominator is equal to 0. So we're going to take the denominator set equal to 0 and solve for x, and we're going to get x equals negative 2 and x equals positive 2. And those are our vertical asymptotes. We've got one more asymptote which we didn't talk about in this class this year, but it's called a slant asymptote. So there's a slant asymptote, and we can find it by using long division. So we're using long division here. 3x cubed minus 0 plus 0x squared minus 2x plus 0. And we'll need a 3x here. Make that there. We'll give me a 2x. So that's pretty much it. That's our remainder right here, right? Plus 2x over x squared minus 4. And it turns out that the line y equals 3x from here is our slant asymptote. So if I was to graph this, I would go start at 0, 0, go up 3, and over 1. And right here, we're going to have a slant asymptote. There's going to be an asymptote that's a line. We're also going to have our positive 2 and our negative 2. And then in here, we're actually going to have our graph. So it's kind of hard to see in this picture. You're not going to have to do this for our test this year, but I just thought I'd go over it because that's the problem. And in case anybody is watching this that isn't part of the class, and you wanted to know how to do a slant asymptote and you're reviewing for your final, and there it is. Alright, so let's take a look at the next one. Give you a second to read the problem. Alright, so let's go ahead and find that. You know what I really should have done is flip these around. So we should have graphed it first and then found the domain and range. So let's do that. Let's graph first and then find the domain and range. So we're going to use step-by-step graphing. I'm going to start with y equals square root of x plus 1, because that's kind of, I know that's a square root function that's moved over 1 unit to the left. Okay, so there's my square root of x plus 1. Then I'm going to subtract 2. So remember that the subtract 2 right here is going to move this whole thing. This one right here is going to move it down 2 units. Down 2 units. And just because I'm probably going to need to know where it crosses the x-axis, it looks like it's going to cross it at 3. So something like that. How did I know it's going to cross at 3? I just set this equal to 0. So then I added 2 over, squared both sides, and then subtracted 1. Then the next thing, so I don't want you to get confused with this thing here. The next thing we do is we're going to do the absolute value. So now the absolute value takes anything that was underneath the x-axis and brings it up and makes it positive. So here we go, 1, 2. And so now we're going like this and like that. And the last thing we're going to do is add 3. So I'm just going to go ahead and add 3 to this graph. I'm going to change the color here. So I'm going to add 3. So I'm going to change this and move it up 1, 2, 3. Move this up 1, 2, 3. And draw my graph. And that'll be the last graph right there. Alright, so now that we drew the graph, we can easily determine the domain and range. So let's go and do the domain and range. We're looking at this orange graph here, okay? So the domain is going to be the x values. Well, we see it starts at 0 and goes on to infinity. So our domain is going to be 0 to infinity. And our range we're looking up and down. So at our y values, where is our y value? The smallest y value is right here. Okay, because our range is going to start here and go up all the way, because this is going to keep going up like that. So it looks like 1, 2, 3. It looks like at 3. So our range is going to start at 3 and go all the way up and keep going up to infinity. All right, so it's much easier to do the graph first and then the domain and range. All right, let's look at the next problem. Find the inverse. It doesn't say inverse function, it just says inverse. So the way we do that is we're going to solve for x and then switch the x's and the y's. So I'm going to add 3 over. So we want to isolate the x. Okay, so whenever we have a square, we're going to take the plus or minus square root on both sides. And now we're going to subtract 2. So I'm going to have negative 2 plus or minus the square root of y plus 3 equals x. So now that I solved for x, I can change this into just flip the x and the y's. So y equals negative 2 plus or minus the square root of y plus, oops, not y. I just said switch it. What am I doing? Come on. X plus 3. All right. And there is your inverse. It's not, we don't know if this is a function. Well, we can just look at it. If we see a plus or minus, I can tell you right now, it's not going to be a function. But the next question says, is the inverse a function? Why or why not? Well, if I graph this one right here, I'm going to have a parabola, and that's shifted over 2 units here and down 3 units. And we know that because this is in vertex form. It goes like this, something like that. This function is not one-to-one, meaning that there is not one x value for every y value and vice versa. And we know it's not one-to-one because it does not pass the horizontal line test. So since this original function, you see it crosses twice right there, since it does not pass the horizontal line test, the inverse is not a function. Okay. All right. So let's do C. Now I already got the kind of the graph here. I'm going to get rid of my horizontal line here because that was just for my horizontal line test. So C, for C I'm just going to add a little red here. So for C, we want the graph less than. This is not a piecewise function. Make sure you understand the difference between an inequality and a piecewise function. A piecewise function will have a function and then a restriction on x. This is an inequality where we have a shaded region below the graph. So there's the graph and we want y values less than that, so we're going to shade below the graph. Okay? And in fact, we need to make this a dashed curve because we have a less than sign. Okay? All right, I think I have time for one more in this video, and then I'll continue on the next one in another video. Okay, compute f of g of 2 and g of f of 2. So for A, the easiest thing to do is we're doing f of g of 2. The easiest thing to do is let's do g of 2 first. So g of 2 is going to be ln of 3 times 2 minus 4, which is ln of 6 minus 4, which is ln of 2. Then I'm going to take this and find f of that. So I'm going to take ln and then plug it in there, and we're going to have the natural log of 2 natural log 2. And you know what? We can't really do much with that. I mean, if we really wanted to, we can make this the natural log of 4 because we can bring the 2 up to the power. But really, this is pretty much it. I mean, we can't do anything more with that other than plug it in our calculator. So let's find g of f of 2. So to do that, first we're going to do f of 2, which is ln of 2 times 2, which is ln of 4. Then we're going to plug that into the g function. And we're going to get ln of 3, ln of 4, minus 4. And you know what? We're done there too. We can't really do anything with that one. Since the ln and the 4, the 4 is subtracted after this ln of 4, so we can't really add those together. This is pretty much it. We're done. So let's move on to B. B says determine the point of intersection algebraically. So remember that a point of intersection is where these two functions will meet. In fact, it's where their y values are equal. So all we're going to do is put this one equal to this one. So we're going to have ln of 2x equals ln of 3x minus 4. And this is easy to solve because we know that the equality property allows us just to take 2x and equal it to 3x minus 4. So I'm going to subtract 3x over. It's an easy equation to solve. And I get x equals 4. I want to plug it in and make sure it works. That looks like it works. That looks like it's fine. It's not extraneous. There's our answer, x equals 4. So that's the x value. We want the point of intersection. So in order for the point of intersection, we plug it back in, and we get ln of 4 times 2, which is 8. This is going to be our y value. So our point of intersection is going to be 4 comma natural log of 8. All right, there it is. And then I'll do the rest of them on a separate video. Thank you.